Now let's talk about measuring angles. Now the measure of an angle does not depend on the length of the sides. The measure of the angle depends on the width or the measurement of the opening between the sides. And so we use a protractor to measure angles, and so I have an example of a protractor here. And this is what you're going to want to be looking for in a protractor, on your protractor. There'll be a point, some have a little hole, but wherever your vertex is, that's where you're going to put that middle point of your protractor. So let's say I'm measuring this angle here. On the vertex, mine has a little dash right there, and we want to make sure the bottom goes directly along the bottom of the protractor. So as we look here, notice the numbers are getting larger from 0, that's a 10-degree angle, a 20-degree, 30-degree, 40-degree, all the way around to 180, which would be a straight angle. I don't want to use these top numbers. That's if I was measuring from this way. Okay, so you want to be making sure you're using the correct arc on your protractor. Now, I can't really tell exactly how wide that angle is open because my second side does not intersect with the protractor, so I'm just going to extend it. So now when I put my base side along the bottom of the protractor, I would look and say, that's really right at about 25 degrees. That's a 25-degree angle. So that's what you're looking at to measure protractor. We'll learn about the different types of angles in this measurement section. All right, so we've learned how to name angles. This particular angle would be angle TSR, or we could say angle RST, or we could just call it angle R because that's the only angle that's on there. But if we want to put the measurement, we're going to have the M in front. The measure of angle TSR in this case looks like it's 50 degrees. You can put a 50 or you can put 50 degrees, or the measure of the angle R would be 50. So if you're talking about a measurement of an angle, you want the little M in front. Measures are numbers. Angles can be congruent, same shape and same size, but measurements are what are equal. So I've already given you a little tutorial here. But if I'm measuring this angle, I want to make sure I measure from the 0, 10, 20, 30, 40, 50. If I'm measuring from this side, I want to use the 0, 10, 20, 30, 40. A corner, like the corner of a page, is a 90-degree angle. So you can usually tell if your angle is greater than 90 degrees or less than 90 degrees. All right, so here they want us to find the measure of angle RST. So we have our vertex right on our corner and our base side along the bottom. This one, the base side, goes along this line, whereas on mine it goes along the bottom of the protractor. And it looks like it's 10, 20, 30. Looks like the measure of angle RST would be 31 degrees. Now some protractors actually can measure more than 180 degrees. They can go a full 360 degrees as a circle. But let's go ahead and put the different types of angles up here. This would be angle T. Angle T's measure is going to be greater than 0 but it's also going to be less than 90. That's an acute angle, A-C-U-T-E, acute. Measure between 0 and 90. You might have an angle that looks like this. We'll call that angle J. Here the angle measure is actually greater than 90, but it's less than 180. 180 degrees is a straight line. We would call this obtuse. And then the last type of angle we have is one that's greater than 180 but less than 360. And we're going to draw the arc there. So we have to tell whoever's looking at this angle that we're not talking about this smaller angle here. We're talking about the larger angle. And for this, the angle measure will be greater than 180, but less than 360. And that's called a reflex angle, or reflexive angle. And just like ruler measurements are not perfect, protractor measurements are just estimates. So you should try to be careful. But again, it is basically just an estimate. So now let's talk about lines. Up until now, we've seen that lines can actually be called by names of points. Here's the line TK. But lines can also have lowercase scripted letters as names. So here's line L and here's line M. Notice the arrows on both sides. Lines are parallel if they will never intersect. They're in the same plane, we'll learn about that, but they will never intersect. And the notation for that are these two parallel lines like that. Lowercase letter, so we have L is parallel to M. Lines that will never meet. So lines can be parallel. Segments can also be parallel. So here we can have line segment RS parallel to line segment MN, because those two segments would never meet. And another way to denote parallel would say, here are my two lines, L and M. They will never intersect. That's our intersect notation. So line L, the intersection of L and M is the empty set. They'll never intersect. It's the intersection is the empty set. So if you're told lines are